In this series of videos, we're going to import a bit of CSV data, and we're going to take a deep exploration into data frame slicing, grouping, and querying, and we're also going to take a look at things like slicing strings, and a couple things with iteration. We'll do this in several different videos, and the basic table of contents is like so. This video, we're going to read the data from the CSV into the data frame. In the video that follows, we're going to slice and filter the data. In another video, we're going to take a look at grouping and aggregation. We're going to take a look at string slicing. We're going to understand a kind of funny loop and conditional syntax that we have in Python that goes for and if. And then we're going to see how to apply functions in a data frame. Again, each of these will basically be separate videos. So let's get started. First, the data set we're using is publicly available on data.cincinnati-oh.gov. It's the Cincinnati Health Department Care Centers. I picked this data set because I like its shape. It has 35 rows, 42 columns, so a digestible amount of data and also a lot of columns and a lot of different columns that we can take a look at. So I've downloaded it, and if you want to follow along, you can certainly do the same. Simply come up and choose... Actually, probably export is the best option and choose CSV format. So I've started my notebook and do our two normal imports. Next, let me go ahead and read the CSV file. And note that I'll simply use panda's read CSV function to read this into ClinicDF and then verify by printing out the results that it did indeed read in our CSV file. And let's take a look at the shape. We see no big surprise here, 35 rows and 42 columns. Now, one thing we will notice is the index isn't all that useful. It's just numbers starting with 0, and it doesn't have a title. And for an index, we need something that's unique. And also, it's a good idea to have something that's a bit concise. I thought about using the Health Center as a unique index for this data set, but it's kind of wordy. And Health Center code looks a bit more unique. The other consideration is there could be two services offered at one health center, and they might have the same name but a different code, like this one, AWL Dental versus AWL Vision. Notice they're both at the same address, but they're actually two different centers. So I'm going to use Health Center code as my index, and I can set it fairly easily. So you see here, I just pass in the column I want to use as an index. I pass it to the setIndex function of ClinicDF. And now we have a more readable index. So Health Center code is over here. And you see instead of 0, 1, 2, 3, 4, we actually have those different health centers. Let's take a look at the shape again. So note that we now have 41 columns where we used to have 42, and the reason for the difference is one of the columns has effectively become the index, and we no longer need the index since we've now named the index. So the column count goes down by 1. So let's take a look at the columns that we have. Simple command list and then pass in the data frame will give us our columns, and notice that now we have health center, address, and street name. But Health Center code is not considered one of the columns anymore, since we've made an index out of it. Let's see what we can find out about our data frame. So when I do a describe command, it tells me some data about the data frame. So count how many items do we have. We see zip code, latitude, longitude, all have 35 items. What's the mean? Zip code and longitude, that one not terribly surprising. That's pretty much right in Cincinnati. Latitude and longitude, that is. Zip code's kind of funny because there's no real need for a mean zip code, but nonetheless. We also have standard deviation minimum, and then the 25th, 50th, and 75th quartile, and then the maximum value. It's good to look at these because they describe the data that we're looking at, and it can be useful for looking at outliers. If we see a minimum that's below 0 for something that shouldn't be negative, like, what's your age or something like that, that can indicate that we might have some data we need to take a look at. If we see a 75th percentile that's way off from the mean, more than we would expect, maybe we have some outliers there. If we see a max that feels out of range. So a look at these can really be helpful in cleaning up our data, and that's why it's an important part of data mining. Also notice that only 4 columns were described. And why is that? Well, that's because they're the only columns in our data frame that are numeric, and it's just wanting to describe numeric columns here. As a matter of fact, if we're curious to see, the dtypes attribute of a data frame will tell us what each of the columns are and their data type. So health center, address, street name, those all make sense as object because that's going to have a lot of character data in it. We see zip code is an int. That one, actually, we might want to make an object because a lot of international zip code have alphanumeric characters in them, especially in England. Zip codes didn't have letters in them. Phone string actually makes sense there because we're probably not going to do a lot of math on it. Now we take a look down here and we have close times, and those are objects which are strings. Now we might want to do some transformation of that data because we might want to do a report on which health centers are open latest, which ones close earliest, or how many there are. So we'll explore that in a future video, but that is to a degree a complex type. If we look at the raw data, we know that the open and close time typically has an hour, a colon, a minute, and then an AM or PM indicator. And zoom up on one up here. There we go. So yeah, that would indicate that it's a string data type because we have letters in there, characters. But if we want to do some interpretation of the data, we need to transform it first. We may need to pull the hour out or the minutes out or something like that, and maybe even do a conversion based on AM PM to bring it to 24-hour time. And those are things that we'll explore in a later video. But for now, we've seen how to load the video, or load the data set rather. We've seen how to take a look at some of the data that DataFrame provides on our numeric columns. We've also seen how to look at data types, and that will get us set up for our next video. Look forward to seeing you then. Thank you.